Okay, we are going to be taking a look at double replacement reactions and how to predict what the product of those double replacement reactions will be. So just to review, double replacement reactions are identified by having two ionic compounds in the reactants, specifically two ionic compounds that are aqueous, that are dissolved in water. Okay, so we're always going to see that when we start with a double replacement reaction. And then what happens is when you mix these two solutions together, when the reaction happens, what they end up doing is the cations end up switching partners. So every ionic compound is made up of a cation, a positive, and an anion, a negative. So in this solution right here, it's calcium bromide. Calcium is your cation, bromide is your anion. And in this one, silver nitrate, silver is your cation, your positive, and nitrate is your anion, or negative. The two cations will basically switch partners so that the silver will end up pairing with the bromine and the calcium will end up pairing with the nitrate. But in order to do that, we have to take into account the charges of those different ions, because when they switch partners, sometimes the formulas end up changing. The number of atoms in each formula might end up changing. So one of the first things that I'm going to do is I'm going to go through and identify the charge of each of the ions involved. Calcium, we know, is a +2. We can get that charge from looking at the periodic table. Bromine is a -1. Silver is a +1. Silver is one of the transition metals, but if you remember, I told you that silver always has the same charge. It's always a +1. And nitrate is one of the polyatomic ions that you memorized. Nitrate is a -1. Okay, so now we know the charges of all those individual parts. Now what we're going to do is we're going to go ahead and figure out what the formulas for the new products would be. I'm going to switch cations. So my silver, which is a +1, is going to bond with bromine, which is a -1. Okay, so this silver is going to come over and bond with bromine. Bromine is a -1, silver's a +1. So if we do the crisscross method, you'll see that you only need one of each. So you're going to end up with AgBr. Now you'll notice that's different. Up here we had two bromines in this formula. We only need one in this formula. There were two here because calcium was a +2. And so we needed to have two bromines to make it electrically neutral. Here, because bromine's a -1 and silver's only a +1, we just need one of each, okay? So one of my products over here is going to be AgBr. Now, I'm going to bond the calcium with the nitrate. So once again, I'll figure out the formula. Calcium is a +2 and nitrate is a -1. If I do the crisscross method, this 2 is going to come down here. It tells me that I need 2 nitrates, and this 1 is going to come down here and tell me that I need 1 calcium. So in the case of this one, I need 1 calcium and I need 2 of the nitrates. But remember, this whole thing, I need 2 of this whole thing. Whenever I need more than 1 of a polyatomic ion, it has to go in parentheses. So my nitrate is NO3 and I need 2 of them. So this is the formula for the second part of this reaction. CaNO3 2. And those are the two products of this double replacement reaction. Now, later on, we're going to talk about figuring out whether they're still aqueous, if there's anything else happening there. So we'll get to that in the next part of this lesson. Okay, let's do another example. Here we have sodium chloride, aqueous, plus lead 2 nitrate, aqueous. Okay, so once again, 2 ionic compounds that are aqueous, and they're going to undergo a double replacement reaction. We want to figure out what the formula for the products of this reaction will be. Okay, so the first thing we're going to do is we're going to look at the charge of the ions involved. Sodium is a +1. We can get that on the periodic table. Cl is a -1. We can also get that from the periodic table. Over here, lead is one of the ions that can have more than one charge, but you can determine its charge based on what it's bonded to. In this case, it's bonded to nitrate. Specifically, it's bonded to 2 of them. So nitrate is a -1, but because we have 2 of them, that means the total negative charge is -2. So that means that my lead is going to be +2. Okay, so now I know the charges of my ions involved. I'm going to be switching cations, which means that my lead is going to come over here and bond with this anion, chlorine. So if I have lead, which is a +2, and chlorine, which is a -1, if I do the crisscross method, that tells me that my formula is going to be PbCl2. 2 chlorines, that 2 came from here, 2 chlorines, and 1 lead. Now I'll do the same thing. My sodium is going to bond with my nitrate. So sodium is a +1. My nitrate, NO3, is a -1. Now, there were 2 nitrates up here to go with this lead, but nitrate itself is just NO3 with a -1 charge. They +1, -1, so I just need 1 of each. So that formula is going to be NaNO3. So those are the 2 new products for this reaction. So I'm going to go ahead and write those up here. PbCl2 plus NaNO3. Now, you will notice these equations are not balanced. Once again, we have not talked about balancing equations yet, so we are just looking at making sure the formulas are correct. You can't balance an equation until the formulas are correct. So I just want to make sure that you understand how to do that part first. So these are the formulas of the 2 products of this reaction. Okay, here's the final example that we're going to go through. And this one has a little hitch in it that you're going to see quite frequently, so I want to make sure and point that out to you. Okay, we have calcium hydroxide, aqueous, which means it's dissolved in water, along with hydrogen chloride. This is hydrochloric acid, is its common name, but HCl, also aqueous. Okay, so 2 ionic compounds, aqueous meaning they're dissolved in water. Okay, so once again, what we want to do is we want to switch the cations. Okay, so in this case, my positive or my cation is calcium, and in this case is my hydrogen is my cation, and I'm simply going to switch them and form new compounds. So let's start with the hydrogen. Oh wait, we have to identify their charges first. Calcium is a +2. Hydroxide is a -1. We have 2 of them in this formula, but OH is hydroxide and it's a -1. That's one of your polyatomic ions. Over on this side, hydrogen is a +1 and chloride is a -1. Okay, so now I'm going to switch my cations. So my hydrogen is going to come over here and bond with my hydroxide. So hydrogen is a +1 and hydroxide is a -1. So we just need 1 of each, and that's going to give you HOH. Now, you might take a look at this and say 2 hydrogens and an oxygen. This right here is water. So when I rewrite this in the equation, I'm going to write H2O. It's water. Anytime a hydrogen ion comes together with a hydroxide ion, they're going to form water. Okay, just so you recognize that. I won't mark it wrong if you write it like this, but it should be written like this, so it's more recognizable. Okay, so that takes care of that one. Now my calcium is going to bond with my chlorine. So calcium is a +2. That's going to bond with chlorine, which is a -1. So if I do crisscross, that tells me that I need 1 calcium and 2 chlorines. So these right here are the 2 products for this reaction. So I'm going to go ahead and write those up here. H2O plus CaCl2. Once again, this reaction is not balanced. We're not balancing the equations yet. We're just making sure we know how to write the product formulas correctly.